write all this out here. So we've got kilos in the bloodstream. Their job is to deliver the fatty acids to our cells, okay? LPL, or lipoprotein lipase, is the enzyme that allows those kilos to release the free fatty acids. Free fatty acids will be abbreviated FFA. Fatty acid will be FA. Okay? Now this is strictly dependent on need. Okay? So if your cells need the energy or need the fuel to produce energy, then this LPL at the body cells is then going to take it in and use it. Now, if you don't need it, what's going to happen is those chylomicrons are then going to find an adipocyte. And adipocytes are your fat cells, your fat storage cells. They also have their own LPL and will take the fatty acids, repackage them into triglycerides, and store them away for later. Okay, so based on energy need, the kilos will deliver free fatty acids to user cells, or deliver the free fatty acids to adipocytes for storage. Okay? So what does this mean? So this is where physical activity, something different than exercise, comes into play. When you stand rather than sit, you increase your need. So it's going to increase this delivery of the free fatty acids to, say, skeletal muscle, heart cells, and it's going to increase the activity of that LPL. If you take the stairs versus the elevator, same thing. You're increasing your need for these fatty acids. If you walk rather than drive, or ride your bike rather than drive, you increase your need. And so physical activity, is it working? Okay. Physical activity is the non-structured movement. Exercise is your structured movement. And so how could you increase your physical activity over the course of the day? As you stand rather than sit. You walk rather than drive. You take the stairs rather than the elevator. And so research has actually been done to specifically find out what amount of time you need to be active every hour to keep this LPL activity up. Imagine LPL is like a computer. Okay, when your screen's open, your computer's up, if you don't press any keys for a certain amount of time, it goes to sleep. LPL works the same way. So imagine if you are sitting for over an hour, LPL goes to sleep, and those fatty acids then get reprioritized to storage rather than utilization. So the actual amount of dose of physical activity has been found out, and the recommendations say that 5 minutes every hour sitting, you should be physically active. It's hard, right? Especially when you're in class. 75-minute class is over 60 minutes. that's what the recommendations say, that they have seen changes in adipose tissue gain and blood lipid levels if someone goes from being sedentary to just using this 5 minutes every hour activity increase. So it's not a very big dose, but it's a very beneficial dose. So just something to think about, something to use to recommend to people that you know that want to increase their activity levels. Just, 5 minutes every hour, which is why your Fitbit vibrates and tells you to move. You've been sitting too long. It's the same information, or this is why. Because this LPL activity will kind of fall asleep, like your computer would fall asleep if you don't create that need. All right. So chylomicrons really only exist in your bloodstream for about 6 to 8 hours after you eat that food. And so they have a very short life. And so, I'm gonna write that down. Exist in bloodstream for 6 to 8 hours after eating. And as they're doing their job for this amount of time, they will deliver those fatty acids, they deliver the goods to the cells, and they will actually shrink in size and get smaller and smaller. Then eventually they will end up in the liver. And this is where we are next, okay? So now these chylos that have done their job then make their way back to the liver. Your liver has specific receptors on it somewhere, membrane I assume, or outer part of the tissue, outer cortex, that then will interact with these lipoproteins, and they're all very specific. The chylos have their own receptor, all the other lipoproteins will have their own receptor, okay? So what happens here is the chylo will end up back in the liver, and then all of that stuff gets recycled and repackaged, okay? So let's go here. So chylos, destination is the liver. Where the contents get repackaged and recycled. Okay. So now this is where it gets even more complicated. Our liver will then start to produce additional lipoproteins from these chylomicron stuff. And it can produce a VLDL, which is considered a very low density lipoprotein. And it will also produce LDLs, which are low density lipoproteins. You guys have heard of the LDLs, right? Mm-hmm. So VLDLs have a pretty short life, kind of like chylos do. And they will eventually become what's called an IDL, or an intermediate density lipoprotein. So you've got what's called very low density. You've got intermediate density. Then you've got just low density, all right? So let's write that down here too. So now, liver then produces more lipoproteins. And their job is to basically pick up where the chylos left off, okay? So the whole point of these lipoproteins is to put the fats in a package that they can move through the bloodstream. This fat is not water soluble. Your plasma is a very aqueous environment. And so these packages have to be formed for those lipids to get places. So pick up Kylos left off. Okay. So that means they're delivering fatty acids to cells. They're delivering cholesterol and phospholipids for cell structure. Remember all of those purposes under the 3 types of fats that we looked at on Thursday last week. Which system in our body really needs cholesterol? Phospholipids and other lipids. Which body system is highly dependent on these lipids? Central nervous system. Their structure is essentially that, lipid structure. All of our muscle cells need triglycerides and fatty acids for energy production, as well as a bunch of other cells for energy production. Anything that has a mitochondria needs it. And then the phospholipids, what are phospholipids actually used for in the body? Cell membrane, yes. So remember, every cell's going to need this stuff, and so these lipoproteins are the vehicle to deliver that stuff, and that's their job. So, I missed a step here. So, additionally, when these chylomicrons get formed in the small intestines, let's back it up 1 sec. This is where all of your fat-soluble vitamins, who can name the fat-soluble vitamins?
A, D, E, K.
A, D, E, and K. So this is where vitamin A, D, E, and K from the food also get packaged and delivered in these chylomicrons back to the liver, into the other lipoproteins, and out to the cells. Okay, so vitamin A, E, D, and K also are packaged for delivery into the chylos, and that's how they make it out to the rest of the body. They will either be used by the cell if there's need, or they will get stored away in adipose tissue. So these are the only vitamins that we actually can store away for later use because they're fat soluble. That's another destination or fate of fats in our body. When we get to the vitamins and micronutrients talk, you'll realize the other ones we just pee out. Well, we don't store them away for later use. Okay. Speeding back forward again in this process. So the purpose of these lipoproteins, whether it's a VLDL, an IDL, or an LDL, is to deliver the goods, right? And it needs to be in this package because it doesn't dissolve in water. So why then, if this is such an important purpose, are these LDLs considered commonly called the bad cholesterol? Who's heard that before? Anyone? Yeah? A couple people? So it's situational. So let's talk about that.